Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! To answer this question, we basically need to find the lowest common multiple of the 10 minutes here and the 15 minutes here. So we're going to start off just by doing the 10 and 15 times table. So it'd be 10, 20, 30, and 15 times table with 15 and 30. So the lowest common multiple is 30. So after half an hour, these buses will sync up. They'll both leave at the same time. And all buses start service at 9 o'clock. So it will be half an hour after 9 o'clock, which will be 9:30. So when you look at this graph, it looks like it's going down as well as up. So it goes down to start off with, and then it starts going up, but then it starts going down again. And when you're looking at trends, you're looking, generally speaking, what's happening with it. So if you kind of draw a line to represent roughly where the graph is going, that line is going to go up. So the general view on it, the general trend is that it is increasing. So you can write general increase in emissions. To find out what the value of x is, we first of all have to find out what the value of y is. And we can notice that we've got two sets of parallel lines here, and a line going through them. And we kind of got these f angles, which we have to call corresponding angles. So we know that 2y minus 50 is equal to 78. And we must write down the reason. So corresponding angles. And corresponding angles are equal. Now here we've got an equation and we want to solve it. So we get our lines in. We'll go first of all, add 50 to both sides. So we've got 2y equals 78 plus 50, which would be 128. And then we're going to halve both sides, or divide by 2. So we've got 64. So we know that y is 64. And so we look back at the diagram to find out how we'd work out x. Well, what we can do, there's a few different things we can do. We could work out the fact that these two here are vertically opposite. That would be absolutely fine. But actually, if we look at this part here and this part here, these are also two parallel lines. And we've got this angle here and this angle are going to be alternate. So I can write that down here. So angle ECB is equal to 78 degrees. So this will be 78 degrees. And the reason for that is alternate angles. And then finally, if we know this is 78 and we know that this is 64, because we know what y is, then we can work out what x is. So x equals 180, angles in a triangle, take away the 78 we know and the 64 we know. And the reason for that is angles in a triangle add up to 180 degrees. And just make sure you write down all the reasons as you go. And when we take away the 78 and the 64 from 180, you get 38. So x is therefore 38 degrees. To find the median, we need to have all the numbers in a list from smallest to biggest and find the middle num. Now, we can't do that when we're using a table like this, or it's not very practical to. So we need a kind of different strategy, and the way we do it is to use a simple formula to find the position of the median. Now, the median will always be in the n plus 1 divided by 2 position. So we need to find out what n is, and we do that by adding up all the frequencies there. So let's add those together and you get the sum of f. So those add up to 15. So if you do 3 plus 4 plus 2 plus 1 plus 5, you get 15. And so we've got 15 plus 1 divided by 2. 15 plus 1 is 16, divided by 2 is 8. So the position of the median is in the 8th position. Now to easily find out which group, because it's asking for the class interval, which is just a fancy way of saying a group, so it could be this one, or it could be this one. To easily find out which group the median is in, what we do is a quick running total. So what I'm going to do is add up the frequencies as I go along. So we've got 3 there, 3 plus 4 is 7, plus 2 is 9, plus 1 is 10, plus 5 is 15. And then what I do is just convert those into 3rd, 7th, 9th, 10th, and 15th. So what those numbers are the last time that a number is in that group. So we've got 3 numbers that are in the group 10 to 25, and the 3rd one is the last number in that group. The 4th one, therefore, will be in the 25 to 40 group. So we're looking for the 8th one. Well, the 7th one is the last one in this group. So the 8th one will be in this group here, as well as the 9th. Then the 10th one will be in the next group. So when it asks for a class interval, all we need to do is copy down exactly what the group is. So it's 40 to 55. And don't ever write down 40 to 55 or anything like that. Always copy it exactly from the table. To work out the mass, we will need to find the density and the volume. Density is given to us in the question, but volume isn't. So we need to work out what the volume of this cuboid is. So the volume is just the 33 times the 7 times the 22. So that would be 5,082, and that would be centimeters cubed. And we need to write down the formula for density. So density is the mass divided by the volume. So rearrange this to get mass on its own, because that's the thing we're looking for. So mass equals density times volume. Density is given to us in the question as 2.1 grams per centimeters cubed. Times that by the 5,082 for the volume, and we get the answer of 10,672. And then that will give us grams, because our density is in grams, so that is grams, but the answer is asking for kilograms. So to convert that to kilograms, we just divide by 1,000 and we get 10.672. Then we need to round that to 2 decimal places, and so that would be 10.67 kilograms. So for this question, what we need to do is factorise 40 plus 6. Now factorise means put it into brackets. So if I try, what I can do is I can actually put a 1 on the outside here. So 1 times 40 plus 6 is 40 plus 6, but the question clearly states that it is higher than 1. So we need to find another number that's higher than 1 to factorise this with. So if we look at 40 and 6, well, they're both in the 2 times table. So I can put a 2 on the outside here. 2 times 2t is 40, and 2 times 3 is 6. So what we can do is we can just check that out with smiles and rainbows. Put all my times down there to remind me to times it. So 2 times 2t is 40, 2 times 3 is 6. So that works because that is the same as this in the question. So we know that 2 times 2t plus 3 works. In fact, it's the only one that works with it being an integer. So we therefore know that the known side, because it says it's a known number, is 2. And the other side will be 2t plus 3. And then when you multiply them together, you get the area of 4t plus 6. So our answer, because it says the length is the known number, so that's the length, then we're finding the width, which is this one here. So it's 2t plus 3. The formula for an exterior angle for a regular polygon is 360 divided by the amount of sides. Now here we're given the fact that the exterior angle is 30 and we're looking for n, so we just need to rearrange the equation. We can times both sides by n. And then divide both sides by 30. And so we've got n equals 360 divided by 30. And when you do 360 divided by 30, we get the answer of 12. So it's a 12-sided shape. We can't work out what x is straight away, but we can find this value here. And we know with Pythagoras we can find a third length if we've got other two in a right angle triangle. So a squared plus b squared equals c squared. And a and b were labelled. C is always opposite the right angle, so it'd be 49 squared plus b squared equals 68 squared. And 49 squared is 2,401. And 68 squared is 4,624. So we are solving here, so let's get our lines down. And we're going to start by subtracting the 2,401 from both sides. So we've got b squared equals 2,223. Then we're going to square root both sides, and we've got b equal to 47.148, blah blah blah. Okay, we're now looking at the second diagram, and this time we're going to have a, we've got our b, and we're going to call x the c. So it would be a squared plus b squared equals c squared, but this time a is 39. B we are given as 47.148, we've just worked that out. And we're looking for c, in fact we can call it x now. Okay, so we need to square that. So we do 39 squared plus 47.148 squared, and that will be 3,744 equal to x squared, and we'll just get our lines in because we need to square root both sides, and we get 61.188 blah 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 is equal to x. It says it wants its two decimal places, so that will be 61.19. So this question says that Adrian, Ben and Charlie have some sweets, and the ratio of Adrian to Ben to Charlie is 9 to 6 to 13. But it also says that Charlie got 56 more sweets than Adrian. So there's 56 more sweets. Well, looking at the actual parts of the ratio, there are 4 more parts. So plus 4 parts, which represent plus 56 sweets. So the 4 extra parts are worth 56 sweets. So 4 parts are worth 56 sweets. So 1 part would be 56 divided by 4, which is 14 sweets. So all we need to do now is work out how many parts there are. Well, there are 9 plus 6 plus 13 parts, which is 28. And each part is worth 14 sweets. So the total number of sweets will be 28 times 14. So 28 times 14 is 392. So to make estimates from a scatter graph, we've got to first of all draw a line of best fit, which would be something like this. And what we'll do is to find estimate of test score B, given the fact they got 25 on test A, means that we would draw a line up from test A at 25, should be here, and then across, and that's how we would make the estimate. But look at where that is hitting our line of best fit. It's hitting it here. What do you notice about this position here? Well, all of our data is down here. We don't know whether this trend continues up at this point here. We have no idea. For instance, if you were to plot a scatter graph of height against age, we would see it would increase like that, but that line doesn't continue on forever. Like, you're not a 10-foot giant at the age of 30. You do slowly stop growing, and so we don't know whether the trend continues. So we call this extrapolation. So we say that the data has been extrapolated, and what that means is it is probably not accurate. So when you have the data outside the range of the data, when you have a prediction, outside the range of the data, we say it's probably not accurate. If it was inside the data, we would say it's interpolated, and that's actually quite accurate. So I'm going to write out the equation again just to give us a bit more space. And the rule we have here is if we have an x on both sides, which we do in here, we pick the smallest one to get rid of. So we've got a 12x and a 7x, and so the smaller number, or the smaller x, would be the 7x. So we're going to get rid of that first. So we've got our lines in, and we're going to take away 7x both sides. And so 12x take away 7x is 5x, and the 7x is gone, so it's just equals to 46. Then we've got the minus 4 to get rid of, so we're going to add 4 both sides. And then we've got this times 5 here, so we're going to divide 5 both sides. So we've got x equals 50 divided by 5, which is 10. So the only way of answering this question is to work out what these are as ordinary numbers. And so 7 times 10 to the power of 7 would be 7, 1, 2, 3, 4, 5, 6, 7. And 9 times 10 to the power of 4 would be 90,000. So that would be 9, 0, 0, 0, 0. And so we're just subtracting them like that. And so we'll get 6, 9, 9, 1, 0, 0, 0, 0. And obviously if this is on the calculator paper, just type it into your calculator. There are no tricks here. You can't do anything with the 7 and the 9. You're not subtracting powers or anything. You're just literally typing in what it says. And there's a button on the calculator like that that you will need to use. So if you don't know what that is, ask your teacher or ask someone to help you out with that. So we're going to first of all convert the 11 litres into millilitres. So we're going to do 11 times 1,000, which would be 11,000. Okay, so we're going to just draw a line, like a number line. And we're going to have the 11,000 in the middle. Now, what would be the next one down if we're looking at to the nearest 10 mil? So we're going to add a 10 mil on, which will be 11,010, and we're going to take the 10 mil away. So 11,000 take away 10 mil will be 10, 990. Now when we're looking at limits, with the upper and lower part of it, we are looking at halfway points. So halfway here and halfway here. So this halfway point will be 10,995, and the next one will be 11,005, and that's the halfway points. And so that is going to be our upper and lower bound. And we just need to say that V can be anything above the 10,995 and including that, and it can be anything below 11,005, but it can't include that, because if it did, if it was 11,005, it would have rounded up to 11,010. So we're going to start off with 100%, and it says that the card depreciates. That means it goes down by, so it goes down by 1.7% every year. So we do 100 take away 1.7, which is 98.3, and that's percent. And we want that as a decimal, or as a multiplier we call it. And so we just divide it by 100 to make it into a decimal, 0.983. And that's our multiplier. And the beautiful thing about a multiplier is we just need the amount of years. Well, it says from 1980 to 1985. So that's going to be 5 years. So it's going to be 5 years. And so what we do is we get the original amount, which was 2,245, and times it by the multiplier 5 times. Now I can't be bothered on my calculator to times it by 0.983 5 times. So what you can do is you can do it to the power of 5, which basically means the same thing. And that gives us 2060.553. And when we round that, that would be £2,060 and 55 pence. So asked to find the bearing of Freetown from Gamley. So that is this angle here. And so what we're going to do is we're going to find this angle, and this will obviously be 90 degrees because the hiker walked west, and it's against the west line and the north line, so it's definitely 90 degrees. So we can work out what the bearing is if we know that angle inside the triangle. So we're going to start by labelling the sides. Well, we've got 90 degrees here, we've got hypotenuse here, we've got the adjacent here next to the angle, and we've got the opposite, which is across from the marked angle. Here we're not using the hypotenuse, so we can cross that out, and we can do our SOHCAHTOA. And the only one that doesn't have the hypotenuse is TOA. And so we're doing tan x equals the opposite, which is 49 over 98. Get our lines in. And we're going to do the inverse tan to both sides. So we get x equals, and we do inverse tan, which is 26.565, blah, blah, blah. Okay, so we know that the whole of the way around up until this point is 270 because we've got this 90 degree left. So what I'm going to do now is we're just going to work out the bearing. So bearing, we're just going to do 270, take away the 26.565, blah, blah, blah. And that gives us 243.434. Blah, blah, blah. It says it wants it to the nearest whole number, so that's going to be 243. There are two shapes we need to find the volume of. There's this cylinder here and this hemisphere here. So we might as well start with this cylinder. And the formula for the volume is pi times r squared times height. So it's the radius is 9, so 9 squared times the height, which is 30. And when we work that out, we get 7,634.070, blah, blah, blah. Next is the hemisphere. To find the volume of the hemisphere, well, the volume of a sphere is 4/3 times pi times r cubed. But because it's a hemisphere, we just times that by a half. So it's half times 4/3 times pi times r, which is the radius, which is 9 cubed. And that gives us 1,526.814, blah, blah, blah. And so the total volume is 7,634.070, blah, 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 plus the 1,526.814, blah, 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 which equals 9,160.884, blah, blah, blah. it says it wants it to 2 decimal places, so when we round that we get 9160.88. So to draw a box plot we need 5 points. We need the lowest point, lower quartile, median, upper quartile and highest point. Now we already have the lowest and highest points, so we can put those onto our box plot now. So the lowest point is at 0 and the highest point is at 30, as we can see on the cumulative frequency graph. So we need to now find out where the median is. Now the graph goes up to 20, the actual line goes up to 20, so the median we're going to find at 10. We're just going to draw a line across and down, and that looks like it is 17. So our median will be at 17, so we're just going to draw a line at 17. Get it just perfect, there we are. Okay, next thing we're going to look for the lower quartile. So if the median we drew a line across at 10, the lower quartile would do it at 5, which will be here. So that's at 12. So we're just going to draw a line up from 12. Fill in this box, and we can actually fill it in with the lowest point. And lastly, we need our upper quartile, and we do that by adding the 5 and the 10 together to make 15. So we're going to draw a line across from 15 and down, and that's 23. So a line up from 23. Try and get this as nicely as I can. I need to move that line a little bit. Oops. There we go, and let's fill in the last bit, join it up with the highest point, and there's our box plot. So the first thing to notice with this question is we've got an isosceles triangle between O, B and A, because these are both radii, and so what we can do is we can find this length here, or this angle here, by doing 180, take away the 40, equals 140 degrees, and because it's an isosceles we do 140 divided by 2, which is 70 degrees. So we know this is going to be 70 degrees here, and whenever you write down working out like this, so the first one would be 180 take away 40, you need to write down y, so you put in brackets angles in a triangle, and then the second one you would put in brackets isosceles triangle. That's why that's 70. That's why we halve the 140. Okay, so the big thing here is that we can now work out what this angle is. This angle is the 10 degrees plus the 70 degrees, which is 80 degrees. And we use a circle theorem here called the alternate segment theorem. And what the alternate segment theorem states is if you've got a tangent and you have a triangle coming off it, which we do here, then the angles here and here will be equal, and also the angles here and here will be equal. It's basically the angle between the triangle and the tangent and the opposite side of the triangle. An alternate segment theorem is quite hard to spot sometimes, so we know that x is going to be 80 because it's going to be equal to the angle at CBA, and what we must write down is alternate segment theorem. You must have those 3 words written down, and it's crucial that you write them down in that order, and you don't call it an alternate segment or a segment theorem. It has to be those 3 words, and in all mark schemes it will have those 3 words written down. And normally there's a mark for a non-circle theorem proof, so angles in a triangle or angles in an isosceles, or both of them for this question, and then a mark for the circle theorem itself. So make sure you write down all the reasons. We're going to write this out again just to give us a bit more space. So we've got S equals 4 minus 13t over t minus 5. I'm going to get our lines in. Okay, so the first thing I need to do is get rid of this fraction. Always get rid of any fractions. I'm going to do that by multiplying both sides by t minus 5. So we're going to end up with s brackets t minus 5 equals 4 minus 13t. I'm going to break open those brackets just by multiplying them out. So it's st minus 5s equals 4 minus 13t. And the objective here is to get all the t's on the same side. So I'm going to add the 5s and I'm going to add the 13t. So add 5s and then add 13t. And so effectively we're just moving this on the other side and this on the other side. So we're left with st plus 13t equals 4 plus 5s. Now when we've got the t's on the same side, we can factorise out the t's. So t bracket s plus 13 equals 4 plus 5s. And then we can get rid of this by dividing both sides by s plus 13. And so we're left with t equals 4 plus 5s over s plus 13. So our answer is 4 plus 5s, all of that over s plus 13. And it can be either way around, so I could have 5s plus 4 over 13 plus s, or anything like that. I'm going to start by labelling this triangle, and so I'm going to pick a lowercase a here, uppercase A I mean, for the angle, and then we go opposite it to mark the length with a lowercase a. I'm going to do a capital B here, and then go opposite it to do a lowercase b, and then obviously a capital C here, and then a lowercase c here. Now notice the c's aren't involved in this question at all. It's just the capital A and the lowercase a, and the capital B and the lowercase b. Now when you've got two pairs of angles and sides, you're going to be using the sine rule. Now, the sine rule is either sine A over A, or it's A over sine A. Now, when we're looking for a length, we put the length on the top. So it's going to be lowercase a over sine capital A equals lowercase b over sine capital B. Okay, so we're going to fill in the values. So A is x, capital A is 38, lowercase b is 4, and uppercase B is 67. Now you'll only ever sine an angle, so if you ever put a 4 in there or something, that's not going to be right straight away. Okay, let's work out what 4 over sine 67 is, and that's 4.345 blah blah blah. So we're going to solve this. It's going to be a nice easy solve today, because all we need to do is times both sides by sine 38. And so that will give us 2.675, blah, blah, blah. And when we round that, we get 2.68. I'm going to start off by labelling this triangle. So we've got a big A, big B, big C, and the opposite ones are little a, little b, and little c. And we've got to figure out whether we're using the cosine rule, sine rule, or something else. We've got 3 lengths, and we're looking for an angle. So whenever we've got 3 lengths and an angle involved in the question, it's definitely going to be the cosine rule. And we've got to figure out which of the cosine rules we're using, because there's 2 variants, one when you're looking for a length and one when you're looking for an angle. And we're clearly here looking for an angle. So the cosine rule I'm going to use is cos A equals b squared plus c squared minus a squared over 2bc. And all that is, if you don't know what this formula is, it's just a rearranged variant of the a squared equals. So it's just rearranged, and it helps if you remember both of the formulas for the cosine rule. It does make things a bit easier. So we're going to write it again, but this time with all of the numbers and letters in that are in the question. So instead of b squared, we've got 9 squared plus, and then the c squared is 6 squared minus the 4 squared over 2 times b, which is 9, times c, which is 6. And when you do that on the calculator, you get 0.935 blah blah blah, but that's what cos x equals. So if we try and solve that now, all we need to do to both sides is the inverse cos. So we're just going to do the inverse cos of 0.935 etc. that's on the calculator, and that gives us 20.741 blah blah blah, and it says it wants its 2 decimal places, so that's going to be 20.74. Capture-Recapture is a way of estimating total population sizes, and it uses a really nice formula, which is n equals little n times little m over big N. Now, n and n, the little ones, are are sample sizes. Okay, so they're the size of each sample, and this big M here is the amount that were marked in the second sample. Okay, so n is the first sample, m is the second sample size, and then m is marked. So marked in the second sample, because obviously you're going to mark all of them in the first sample. So what you do is you catch an amount of a trout in this case, mark them all with any kind of marking, and then you capture again, and capital M is the amount that were marked from the first sample in your second sample, and then capital N is the estimated population size. So that's what you think the overall population size is going to be. So here we caught a sample of 84 and tagged them all, and then we released them. Then we caught a sample of 56, and we found that 15 were tagged. And so when you do the sums on that, it's going to be 313.6. And when you round it to the nearest integer, because obviously you can't get 0.6 of a trout, we estimate it to be 314. With this question, we're going to first of all have to find a length before we can find the length AF, and it does involve us thinking in 3D. What I find sometimes useful though is to draw kind of a 2D representation of the 3D. So I'm going to look at this triangle here, and I'm going to notice that I need to find length BF. That's going to be my objective at the start of this. So I'm just going to draw out this triangle again, but in 2D just to make it a bit easier. And BF is this length here, this is 6, and then this is 9. So we're going to use Pythagoras, so it will be sort of A squared plus b squared equals c squared, so it would be 6 squared plus 9 squared equals bf squared. 6 squared plus 9 squared is 117, and then we just get our solving bit in, just to square root both sides. And I can leave this as square root 117 for now. Okay, the actual length that we want is AF, which is this one here. And I'm going to create the right angle triangle using this bit here. So let's just draw that out. Now the top bit is AB, which is the same as the bottom. It's going to be 14. It's going to be the same as EF. Then the BF we've just found is root 117, and we're looking for AF. And this is the right angle. I didn't show the right angle on the other one, but it should be there. Okay, so we're going to use our a squared plus b squared equals c squared. and a squared is 14 squared plus square root of 117 squared equals af squared. So 14 squared is going to be 196. Now root 117 squared is just going to get rid of the square root, so it's just going to be 117. And when you add them together you get 313. And again get our solving lines in. Square root both sides. And this time we're actually going to square root 313 because we need a decimal answer. So it would be 17.691 blah blah blah. It's equal to AF. And it says to 2 decimal places, so that's going to be 17.69 centimetres. To answer this question, we're going to do something a bit weird on the calculator. And this is a method you might not know, but it's the quickest method for answering this question. And what iteration basically is it's feeding the previous solution into the iterative formula to get the next solution, and you keep going and it will get closer and closer to an answer, and then we write down that answer. But on our calculator what we're going to do is just press the button 1 and then equals. Now what that will do is it will store the 1 that we have here in our calculator. Then we're going to type in the cube root button and the 1 will disappear. That's not a problem because the next thing we're going to press is answer plus 10. So on your calculator it should look like this, the cube root and then answer plus 10. When we press the equals button, what will happen is it will work out what the next number is in our iteration. So if we press equals, we get 2.22398 blah blah blah. Because we're looking for it for 3 decimal places, we're just going to work that out to 3 decimal places. So it'll be 2.224. Then all we need to do now is press equals again, because instead of using the 1, it will use the 2.223980091 etc. as the answer. So I'm going to press equals again, and lo and behold, I get 2.304. Press equals again, 2.309 equals again, 2.309. Now, when you get the same answer twice, you can stop. That is our answer. So our solution is 2.309 to 3 decimal places. I'm going to first of all just focus on this rectangle here. And we know that to find the area of a rectangle, you multiply the two lengths. And when you've multiplied them for this rectangle, we get 697. But let's write down what A is equal to. And A will be equal to the area, which is 697, divided by the length at the top, which is x plus 30. Now let's focus on the other square, or the other rectangle. And this time we have A equal to the area of it, which is 1870, divided by the 10x. Now because both of these are equal to A, we can actually just get both of these fractions equal to each other. And what we can do is work out what x is going to be. So the first thing I'm going to do is I'm going to put my lines in because we are looking to solve. This is probably going to take a while. And I'm going to times both sides by the x plus 30, so I can get rid of the denominator on the left hand side. And so this will just be 697 on the left hand side because that gets rid of the denominator. And it will be 1870 times x plus 30, and then all of that over 10x. Same thing again, but I'm going to get rid of the denominator on the right hand side, so I'm going to times both sides by 10x. So we've got 697 times 10, which would be 6,970x, because it's 10x. And it won't actually do anything to the right hand side, but I'm going to expand the top, the numerator. It just gets rid of the denominator. So let's expand while I'm here. So that would be 1,870x plus, was it 56,100? I believe that's right. Yep. Okay, so now we've got x's on both sides. So we look and see which one is the smaller amount of x, which is the 1,870, and we're going to take that away from both sides. So take away 1,870x from both sides, and that will leave 5,100x on the left hand side, and then obviously we've got the 56,100 on the right hand side. And we want to get rid of the 5,100, so we're just going to divide both sides by 5,100. And so we've got x equals 11. So now we know x is 11, we can pick one of the equations that we had at the start, and I'm just going to pick the first one, and we can just feed in the value of x. So a equals 697 over, instead of x, it's going to be 11 plus 30. And when you do that, you get the answer of 17. So A is 17. We're going to first of all work out what the function f g of x is. And to do that, what we're going to do is just feed in the value of gx, the function, the kx plus 2. We're going to feed that in as the value of x in the f of x function. So instead of 4x, it'll be 4 lots of kx plus 2 and then plus 3. Now this says that fg, when 4 is put into it, it gets an answer of 187. So when 4 is put into it, well, let's put that 4 into it. So 4 brackets, and it's k times 4, so that's 4k, plus 2, plus 3, and it says that that will equal 187. So we've actually got something we can solve here. So I'm just going to rewrite that, but actually I might expand the brackets as well while I'm at it. So 4 times 4k is 16k, 4 times 2 is 8, plus 3 equals 187. And let's get our solving lines in. Okay, so first thing we're going to do is, well, we can add the 8 and the 3 actually while we're here. So 16k plus 11 equals 187. So we're going to take away that 11 from both sides. So we've got 16k equals 176. And then we can divide by 16 both sides. So we've got k equals 11. So answer is 11. So we're finding the area underneath this graph, and that's how we're going to estimate the distance, because the distance is the velocity times the time. And so if we work out the area under the graph, then we've got the distance. But the issue is that we don't understand things like calculus yet, and we've got to use this thing called the trapezium rule. Now for the trapezium rule, what we do is we draw these lines up and we draw little trapeziums, like so, all the way up it, and in regular intervals. So here you can see the interval is every 2 seconds, and we draw these little trapeziums. Now it's often helpful to actually label them, so I'm going to label them A, B, C and D. And the formula for a trapezium, or for the area of a trapezium, is half brackets A plus B close brackets times H. Now A and B are the parallel sides, and H is the perpendicular distance between them. So let's do this for the area of A. So it's going to be half brackets. Now A and B are the parallel sides, so it's going to be this side here and this side here. So that would be 2 plus 1. H is the perpendicular distance between them, so this bit here. So it's on its side, so the height is actually the width, isn't it? So we're going to times that by 2, and that gives us 3. Okay, and you notice here that the half and the times 2 actually cancel each other out, so all we need to do is just add the A and B's together. So to find out what B is, we're just going to add the 1 and the 2, and B will equal 3. To find out what C is, it's 2 plus 5, which is 7, and to find out the area of D, it's going to be 5 plus 10, which is 15. So that's a bit of a quicker way of doing it than having to type it into a calculator each time. Then to find the total area, it's just going to be all of those added together, which will be 28. Now notice, this is useful for some questions, notice that actually there's a bit of a gap here, and I'm just going to shade it in green. It's a bit of a gap between our trapezium and the actual distance under the curve. So here the trapezium is actually adding on a little bit more area than we want it to. And what you'll find is a curve that looks like this, the trapeziums will actually add too much, so the area will be too big. And for curves like that, the trapeziums will actually not give enough area. So sometimes there's questions on whether it's an overestimate or an underestimate, and that's how you can tell. This question is all about completing the square, but we've got to do something first. We have a coefficient of the x squared there, and we want to get rid of that. Whenever we do the completing the square, we need to have just x squared on its own, ideally. So we're going to divide out that 3, and so we're going to have 3 brackets, and then we're going to have the x squared minus 10x, close brackets, minus 11. Then we're going to complete the square with x squared minus 10x. So we're just going to copy in that 3 brackets. And how we do this is we create a bracket and we put the x at the start minus half of the coefficient of the x, so half of the 10 would be 5, close bracket, squared. Now I'm going to leave that half done because down here I'm just going to, well, across here I'm just going to expand that and show what that creates. So x times x, so that's the same as x minus 5, x minus 5. So we get x squared minus 10x plus 25. So notice here it creates this plus 25, which we've got to deal with. And we deal with that by removing the 25, which we do here. Close brackets, minus 11. So the blue parts haven't changed. The kind of turquoise parts are the completing the square bit, but the minus 25 just removes that 25 that the x minus 5 squared brackets create. Okay, so we need to get that minus 25 outside the brackets. So we're going to expand the brackets slightly. Going to leave the 3 on the outside of the x. In fact, let's keep the color scheme going. So we're going to have the x minus 5 squared bit there. 3 times minus 25, it's minus 75. And then we've got this minus 11 at the end. Okay, and we're very, very close to finishing. All we need to do now is sort out the minus 75 and the minus 11. And when we subtract those two, we get minus 86. Now the m part is going to be 3. The p part inside the bracket is going to be minus 5. And the q part is going to be minus 86. So I'm going to first of all just draw out the diagram a bit bigger, just so we've got a bit more space. And we're looking at going from B to M, and M is about here. Now the first thing to notice with M, I'm just going to quickly label the other parts on, is that the ratio of A to M is 1 and M to C is 4. So the ratio is 1 to 4 between the two. And what is really helpful sometimes is just to label in the kind of section. So if A to M is one section, we've got 4 of the sections from M to C. So just put like notches there to show the 4 sections. And we can see straight away that A to M is 1/5 of that distance. That's why it's a nice, easy way to show that A to M is 1/5 of that distance. Let's just put a nicer 5, there we go. And so we're looking at going from B to M, but we can't go directly from B to M. We've got to go from B to A to M, and that's going to be the direction of travel. Now, we don't know the name of the road between A and M. In fact, we don't know the name of the road between A and C. We've got to first of all work out what that's called. So what we're going to do is we're going to go from A to C by going down here and then up here. So we can find out A to C is going to be going backwards down A, then up B. Now A to M is going to be 1/5 of A to C. Now if A to C is minus A plus B, that means A to M is going to be minus 1/5 A plus 1/5 B. Now we're asked for the vector B to M, and we know that that's going to be B to A plus A to M. We know B to A because it's labelled, it's just A. And we know A to M because we've worked it out down here. And it should be minus, let's get rid of that, because we know it's going to be minus 1/5 A plus 1/5 B. And so A minus 1/5 A is going to be 4/5 A. And then we've got the 1/5 B. So it's going to be 4/5 A plus 1/5 B. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.